The objectives for this video are to understand the population variance and standard deviation, how they are calculated, and what they measure, and to learn how to use the correct symbols for the population variance and standard deviation. This time series graph shows the number of home runs hit for both major leagues from the year 1901 to 2013. The mean of this population is 2,346 home runs. But looking at this graph, we can see that there is a fair amount of fluctuation in the number of home runs hit from year to year, particularly once we get past the 1960 season. This brings up a question that is asked as frequently as any other in statistics. How much variation exists within the data? One of the measures that is used to quantify variation in a data set is the variance. The variance is the average of the squared deviations between each data value and the mean. In order to find the variance, we will follow a process. Step 1 is to find out how far does each data value lie from the mean. We will find this by finding the deviations from the mean, which just means we will subtract the mean from each data value. In step 2, we will find the squares of the differences between the data values and the mean. That just means that we will square each of the values we found in step 1. In step 3, we will find the average of the squared differences between each data value and the mean. So we will add up all of the values we found in step 2 and divide by the size of the population. The truncated table below contains the data used to form the home run time series graph. Notice that the table contains the year, the number of home runs, and then 2 columns that we will complete with the deviations from the mean and their squares. Recall that the general rounding rule tells us that we should do no rounding until the final calculation has been made, so we are going to work with as many decimal places of the mean as is practical. To begin, we will subtract the mean from each data value. In the first row, for the year 1901, that calculation will be 455 minus the mean. Once that calculation is done, we will square it in the next column. We will continue this process until it is complete for each row in the table. Note that the larger the deviation, the larger this squared value will be. The population variance is given the symbol sigma squared. Recall that it is the average of the squared deviations from the mean. So we will need to add up all of the values in the last column. This sum will give us 280615,806.9. Substituting into the formula, we will have that value divided by 113. 113 is the size of the population. The rounding rule for the variance is the same as the rounding rule for the mean. We should round to one more decimal place than occurs in the raw data. Since our data are whole numbers, we should round the variance to 1 decimal place. This brings up the problem of units. The mean for the home runs data set is 2,346 home runs per season. So the units for the mean are consistent with the units for the individual data values. This is why we can compare the mean to the individual data values when we subtract them in the formula for the variance. But during the process, we squared those deviations and then found the mean for the squared deviations. So that means that the units for the variance would be the square of the units for the mean. The problem then is that we can't compare our measure of variation to the individual data values. The solution to that problem is to take the square root of the variance. The result will be a measure that we call the standard deviation. The units of the standard deviation would then be consistent with the units for the mean and the individual data values. The rounding rule for the standard deviation is also to round to one more decimal place than occurs in the raw data. So the standard deviation for this population is 1575.9 home runs. In this video, we learned how to understand the population variance and standard deviation, how they are calculated, and what they measure. We also learned how to use the correct symbols for the population variance and standard deviation.